Okay, before we go on to Venn diagrams, I just want to show you real quick the answers to the classwork. I keep getting messages of needing more space, so I'll work that out with IT later. So here's the answers to that classwork. Now let's take a look at the Venn diagrams. Read about this in your textbook. I'll put something up on activities as well. This blank space here in your workbook, we're going to use rectangles, or what we usually use to show the Venn diagram. These are two sets that are disjoint, so they would be marked like that. Here are two overlapping sets. The orange, you can see, outlines the union of A and B. That's what's in both entire sets, including the overlap. So remember, that's A or B. The yellow here is A intersect B, or we would say A and B. Sometimes we're just looking at one part or another. So this is A only. We would write it as A intersect B complement. So this is how we show it in the Venn diagram. And your book does outline those really well. If we want B only, we would just shade that part that has B and doesn't contain any elements of A. Let's do this example here, 3.11. Use a Venn diagram to illustrate A union B intersect C complement. So what we want to show here is kind of like, think of it as Mickey Mouse ears, that we want everything in A and B, but not any elements of C. I should say A or B. So I want these pieces right here. So if I were going to outline that, well, it looks like just the ears of Mickey. Okay, so that is showing that in a Venn diagram, which can be helpful later. You'll see some of the problems have numbers that we're looking at, or what's in what, where's the overlaps, what's the only piece that we're looking for. Okay, so just a couple more pages here. Cardinality is when we're just looking at the numbers of things. This is in page 84 of your textbook. So sometimes we just need to know how much, and that's where this leads us into probability quite nicely. So without doing this little bit of sets, probability, sometimes it's hard to get those counts to know what percentage chance you have of something happening. We can use these things if we collect some data. We can use it to make predictions. So on this one here, we have a survey of 200 people are asked, what beverage do you drink in the morning? And offers choices tea only, coffee only, or both coffee and tea. Suppose 20 report tea only. So remember, tea, no coffee, right? So think of the idea of the complement we were using. 80 report coffee only, and 40 report both tea and coffee. So that's our intersection. How many people drink tea in the morning? How many people drink neither tea nor coffee? So we would draw our box here, make